So as an example, there is always parameters you can eliminate in your analysis. The simplest example you probably have seen elsewhere is the inviscid flow, let's say potential flow around the circular cylinder or around any body, right? So the flow is like that. And there is a dimensional radius of the circular cylinder or the size of the body. And there is a dimensional free stream quantities. Let's say there is a free stream density that indicates am I doing this analysis in water or in air. There is also a free stream velocity of how fast the flow is coming, right? And we are looking at a two-dimensional flow, so we have x and y. So let's suppose it's a low Mach number incompressible flow for now. Then I know from the incompressible Navier-Stokes equation, my velocity should be a function of not just the x and y, but also all these parameters I'm looking at. So rho infinity, u infinity, and r, right? So in a physical world, this is how the velocity should depend on physical coordinates and the parameters. But if we can non-dimensionalize things in potential flow, that we know that when we non-dimensionalize things, we can take just the radius of this to 1, and the free stream rho is equal to 1 and u infinity equal to 1. The flow field is going to be similar to what we are going to get in this case. And in this case, our u, if we take the u divided by the u infinity, should be the same. So the u divided by u infinity in this case, it's actually the original velocity in the non-dimensionalized case, and in the dimensional case, u divided by u infinity is going to be the non-dimensionalized velocity. It's only a function of x divided by r and y divided by r. All right, so basically we're reducing a quantity, a flow field that depends on 5 parameters to a quantity that depends on only 2 parameters. That's enormously powerful. Have you ever heard of the word called the curse of dimensionality? No? So just to think of computationally, how much computational power do you need for you to understand a 5-dimensional function? Let's just imagine in the simplest case, you can do Cartesian grid in every directions, right? In x direction, you have a grid of 100 grid points. In the y direction, you have a grid of 100 points. In the rho direction, you have 100 grid points. In u and r direction, you have 100 grid points. How many grid points do you have in total? 100 to the power of 5 or 10 to the power of 10, right? It's about, what, 10 billion grid points? It's huge, right? That's for such a simple problem, potential flow around a circular cylinder. And in reality, if you know non-dimensionalization, you only need 2 parameters. That's only 10,000 numbers as opposed to 10 billion. All right, the more you can reduce, the more powerful you are. Okay, so in this case, how do we know that we can reduce the parameters from 5 to 2? Anything you can do to know in advance, you can reduce from 5 independent values to only 2? Yeah?
There are 3 fundamental dimensions involved in the problem.
Exactly. Look at what are the dimensions involved in all of these parameters. All right. So okay. So in this case, we have. Let's look at x. X is the dimension length, right? Y is also dimension length. Rho is of dimension, let's say, mass divided by length cubed. But so we have a new dimension of mass. Velocity is of dimension length divided by time. So we now get a new dimension of time, and we have radius as dimension of length. So we have L, M, and T, three independent units. So that actually indicates that we can reduce the number of independent parameters by 3.